Here's some net ionic equation. Here's a net ionic equation problem. All right, it says write the balanced net ionic equation for the following reaction. And let's write the equation first. Nickel 2 nitrate. Nickel, the cation has a 2 positive charge, and we're going to need parentheses here because nitrate has a 1 negative charge. So that one is, these charges are going to crisscross. So just two goes out there for nickel 2 nitrate. That's in solution, so indicate that a solution of water, and sodium hydroxide. All right, one positive, one negative, they're going to cancel out. All right, and that's going to produce. We gotta switch these around. Switch the cations or the anions. All right, in this precipitation reaction, or this double replacement reaction. All right, so I'll write the sodium first because that's the I don't know, I just like writing the precipitate last, but it doesn't matter. All right, sodium is going to be with nitrate, and they're both have charges of one positive, one negative, so they're going to cancel out when you're writing the formula for sodium nitrate. All nitrates are soluble, as well as alkali metals are soluble, so put AQ there, and then the other component is going to be the precipitate. Hydroxides are generally insoluble. This is nickel, two positive cations, so I'm going to need a parentheses here because hydroxide is a 1 negative charge polyatomic ion. So crisscross that 2 over here, and this is going to be your precipitate. Okay, so next step is to write the go with green here. All right, write the complete ionic equation. That means we're going to separate all of these aqueous species because they're in a solution of water, and so they're all going to, you know what, let's balance this first. Sorry, let's go back, balances. Do this. So we got 2 nitrates on the reactant side, so I'll need a 2 there to balance out the nitrates. Sodium, I have 2 on the product side, so I'm going to need 2 there to balance out the sodiums. I've got 2 hydroxides on both sides and 1 nickel, so we are good. Coefficients are right there. So okay, now we can go and you didn't necessarily have to do that in that order, but just like this is the way I teach it in class, so I'm going to try to be consistent. All right, so we're going to write all the aqueous species as their ions. So ions have charges, don't forget the charges, and there's nickel, nitrate, it's going to have 1 negative charge. Indicate that it's all dissolved in water, put AQ there. Got 2 moles of sodium ions in solution. Not necessarily 2 moles, but the ratios are 2 to 2 for the other ones have 1 mole. All right, hydroxides, 1 negative charge, AQ. Sodium. Make sure you have charges on all of these ions. Oops. Oops. Sorry. Like the bell's about to ring, so I'm a little distracted. Put a 2 there. Charges. All right, and then this is a precipitate, so that's just going to stay the way it is. Put solve there. Nice. All right, next step, cancel out the spectators. Okay, so the spectators are often going to be the at least in double replacement reactions, they're going to be the ions on the product side. So notice that there's 2 sodium cations on both sides and 2, oh man, I forgot the 2 here. 2 right there. Okay. All right, we're going to rewrite what is left, and that is going to be our net ionic equation. All right, let's do that.